Good morning. Now we will go with next question. That is question 3. Find design compressive strength of top chord member consists of two ISA 110 at 13.4 connected back to back to gusset plate. The length of member connection is 3.1 meter. So now we will go with first L is given. L is given 3100 millimeter. So L effective, because we have not given connection, we will consider bolted connection. Generally, we have bolted. So 0.85 into 3100. And we have this value that is equal to 2635 millimeters. Then we have given two ISA 110 means we have connection in this fashion. Top chord we have likewise. Now for compression, we are not interested with connection, and for tension, we are not interested with length. So we are in this fashion. So definitely our value of RZZ is greater than RYY, because RYY we have for whole section. So RYY, we have YY over here and RYY whole over here. And if you remember formula, we have RYY whole, and that is equal to under root of RYY individual square plus H square. And H we have distance between individual axis to the whole axis. And then we have RZZ we have give for this 110, we have value 34 millimeters. Therefore, we have L effective upon RYY 34, R minimum, and that is equal to 2635 upon 34, and we have this value that is equal to 77.5. Then we have to go for B by T. So we have 110 by 8. This is less than 15.7. So this comes 13.7, which is equal to D by T, and less than 15.7. And then we have B plus D by T, that is 110 plus 110 upon 8, and this comes 27.5 greater than 25. And therefore we have to find B plus D by 8 equal to 25. So we have B equal to D. So we have 2B upon 8 equal to 25 and B equal to 100. Therefore we will get A equal to 2 times, as we have AGO and ANC both leg. So 2 into bracket 100 minus T by 2. T is 8 upon 2 into 4. And we have two legs, so we are multiplying it by 2. And we have 100 minus 4, so 96 into 8 into 2. So we have this value 1536 millimeter square. 1536 millimeter square. So now we have AE equal to, we have two angle sections and 2 into 1536, and this comes value 3072 millimeter square. These values we have in table 2, buckling class, and now we have 100 plus 100 upon 8, and that is 25, equal to 25. Therefore, section is semi-compact. And as it is semi-compact, so now we can have value that is 2 into 15363072. Now we have buckling class, that is C. Now try to understand this. I will draw single angle section and explain it. We have like this. So now we have 100, means this value 100. This also 100. So whatever portion which is beyond this is ineffective. Means our section is slender section. So due to this, we have slender section. And then we have to convert this section into semi-compact. So that is 25, and now it is semi-compact. So we have two legs, 1, 2. And what is formula? B minus. What is formula for AGO is B minus T by 2 into T. And now we have A and C equal to AGO, because here we do not have connections. So buckling class, therefore use 9C. And from this we will get value of FCD for 70. Now we have value 77.5, and therefore for L upon R 70 and 80, and we have FCD, that is 152 136. And from this we will get FCD equal to 152 minus 152 minus 136 divided by 80 minus 70 multiplied by 77.5 minus 70. And we have this value of FCD 140 Newton per mm square. Check it, there may be little bit change, and therefore we have PD equal to AE into FCD. So AE is 3072, FCD we have 140, and that is equal to 430 kilonewtons. And therefore compressive strength of two angle 110, 110 and 8 is 430 kilonewtons. Then we have second problem. Design a built-up column with two channels back to back. Actually, we need not require this diagram over here. So, but that was copy paste. Now now we have second example in this. Design built up column with two channels back to back, and we have factored load is PU. This is given 1200 kilonewtons, and then the column is restrained in position at both ends. So we have a restrained in position at both ends. At both ends, and in direction at one end. And in direction at one end. That means we have this column position, that is one end we have fixed and other end we have hinged. So we have diagram of column in this fashion. And therefore we have L effective means this is fixed. So we have L effective equal to 0.8 L. So we have 0.8 and length of column is given 9 meter. So that is given. If you will see the question paper, then you have this data. L equal to 9 meter. This is given. So into 9,000. And then we have 7200 millimeters. So now we have to assume FCD. So assume FCD. So that is equal to, I have assumed 170 Newton per mm square. Therefore, area required equal to PU upon FCD, which is assumed. And therefore, we have 1200 into 10 raised to 3. And FCD we have 170. And from this we will get area required 7058. 7058.82. 7058.82. And then for area required for single channel, and that is equal to 3529.4 mm square. And now we have select channel ISMC 250 at 30.4 kg per meter. Now we have R minimum is always lesser. We should have RZZ should be less than RYY. In this way, we have to provide S, and therefore we have RZZ is given 99.4 millimeters, and therefore L upon R minimum, which is equal to 7200 upon 99.4, and we have this value that is equal to 72.43. Then we have B by TF, that is equal to BF by 2 by TF. BF of the section we have 80 by 2 divided by TF is 14.1. This comes 2.84 less than 9.4. Assume FY 250. Therefore, epsilon equal to 1. 250 MPa. And then D by TW. So D we have 221.8. So we have total depth, that is 350. Sorry, ISMC 250 we have, not 350. ISMC 250. So we have 250 minus 2 into TF 14.1 upon TW. So TW we have 7.1. This comes 31.23, which is less than 84. And therefore, section is plastic. Both we have plastic. Flange is also plastic and web is also plastic. Therefore, section is plastic, and therefore we have AE equal to AG. Now we have to go for buckling class. Buckling class, and for built up column, we have buckling class is C. So we have from this is from table 10. And then we have to find FCD. So we have again the same 70, 80. This is L upon R. And FCD values we have 152 and 136. And then we have FCD equal to 152 minus 152 minus 136 upon 80 minus 70 multiply by 72.43 minus 70, and this value of FCD comes 148.11 Newton per mm square. And then we have PD equal to AE into FCD. AE we have 2 into area of channel section is 3867. This is area of ISMC 250 into 148.11, and that is equal to 1145.48 kilonewtons, which is less than 1200 kilonewton. So if such comes, so I have purposely taken this. So if such comes, so you can say providing to ISMC 300 higher section, which satisfy the requirement. I have purposely taken this in this fashion, and then you need not require to solve it again. But this is most important, providing to ISMC 300 which satisfy the requirement. And then you need not require to solve this one. So basically you can have this, but go on higher side and then solve the problems. So now we will stop here only. Thank you.